Hello again. The aim of this mini tutorial is to do RIPng for IP version 6. So RIPng, RIP next generation, is RIP's answer to routing IPv6 networks. Packet Tracer works okay with it. I think the default route doesn't get propagated across the network in Packet Tracer, so we'll talk about it, but it won't happen, I don't think. Anyway, let's have a look at our network and see what we've got. We've got the same kind of look and feel of what we've had before, but we've changed to IPv6 addresses. So on this green side here, we've got 2001 coffee COFF, then EE network 1, and that's a 64-bit subnet mask. And over on the right hand side here, we've got network 2, same kind of prefix, and network 3 up there. So they're subnetted, all 64-bit subnet masks. And I've got a couple of static addresses chucked in for my PC and server there, that server over here as well. And everything else is acquiring their address through Slack. So that PC there and that PC there should acquire their IPv6 addresses through SLAAC, so stateless auto address configuration. So let's go in and have a look at what we have. So we go into router 1, and if we show run, at the moment I have no IPv6 enabled, apart from putting on the actual addresses. Now one of the things that we need to look at, so on gigabit 00 I have a linked local address, and I've got the actual address of our network. So 2001 COFF1, and I've given it a value of 1 there, that's the host address, 64-bit subnet mask. Now if I go further down, I'll just go down and come back up. On my serials, I only have a linked local address. So IPv6 address, FE80 :1 is the link local for serial 000. So that's this interface going across this way. And FE81 link local again for this interface going up to router 2. And I don't actually need an absolute address on the interface, and we'll see that the routing protocol uses the linked local addresses to distribute routes, and within that, on router 2, if you just do a show run there, we will notice that we've got different linked local addresses. There still have to be different host addresses in there, but that's okay. Now I did leave an IP4 route, which is sad, don't need it, but here's an IPv6 static route, which is the same effectively as the one you have up there. So all the zeros with no bits in the subnet mask, and we're sending out a gigabit Ethernet 01, and this is all fully qualified, so we're putting the next hop address in there as well, which is out of our gigabit 01. And that should be a 2 there actually. We've stuffed that. That should actually have a 2 on it. Might be why my static routes aren't working. We'll just fix this actually. We'll just copy that while we're in here. And we'll say no to that and hit up there and say the next hop address is going to be something else. So we'll just fix that one quickly. Okay, so let's get up and running. We're on router 2. So what we need to do is, first of all, enable IPv6 on our router. So IPv6 unicast routing enables our routing processes to work, and then we need to enable RIP. So IPv6 router RIP, and reasonably similar to what we did with IP version 4. Big difference is we have to put a word in there. So I like Bob. So let's make it Bob2 for router 2. Is going to be the routing process. It's just a name given, and that's it for router 2. Within here, actually, we might have a quick look. If you want to redistribute static, that should be what we need to put in there. So redistribute static is the same as, or similar to, should I say, default information originate in RIP IP version 4. This one says take the static address, which I've just rebuilt, and put it into RIP, this instance of RIP bob2, and propagate it to router 1 and router 3, the pairs running in here. So we'll see how that goes. Okay, so that's all we need to do, those two commands. IPv6 router RIP, and then give it a name, and that should be the same name we use across this router. And if you're going to redistribute, if you're on a border router and redistribute, then that should be what we need to do. Okay, we'll exit that. And now, so what I've just done actually is, unlike RIP version 4, where we actually put in the network commands in the router RIP option, we actually go into our interfaces now. So interface gigabit 0, oops, did I get that right? 00, and we have an IPv6 address already put on that with the link local. So all we need to do is add it, this interface, to this instance of RIP. So IPv6 RIP, and it's going to ask us for a word, so bob2, same word as we used before, and we enable it. That says take this network number and enable RIP on this interface. So if you go for interface serial 000, and it's nice because we can use the up arrow there, we enable it for that one as well, and we'll use the up arrow again to do for interface serial 001, and we type in really quickly IPv6 RIP bob2 enable. Now this name should actually mean something. I've just used a fictitious name, but that's just a name that is only applicable to this router up here, router 2, and it says let's run RIP on those three interfaces, gigabit 00, serial 000, and serial 001. We're running RIP. We're not using it out for the internet, so let's see how we go. Let's do the same on router 1. So conft IPv6 unicast routing. If it's not enabled already, let's enable that, otherwise nothing will work. Then let's enable RIP again, so IPv6 router RIP, and whoops, again we need a name. This one I'm going to call bob1 because it's on router 1. Now I don't need to redistribute anything from that, so that's it. One line enables RIP. Then I go on to my interfaces. So interface gigabit 00 and IPv6 RIP bob1 enable. Interface serial 000, and again IPv6 RIP bob1 enable, and the same for serial 000, and we're up and running. Let's go on to router 3 and have a look what's happening over there. So same commands, third time lucky, eh? IPv6 unicast routing has to be enabled. IPv6 router RIP, give it a name. I'm calling this one bob3, and again no correlation to what's on router 2 or on router 1. It's a local name only for this router, and we've enabled that. Then we go into interface that we want to propagate out, and interface gigabit 00 is the one I want to do, and on that we go in IPv6 RIP, the word that we've just created, bob3, and enable. Good. So we'll go onto our serial 000 and same again, IPv6 RIP bob3 enable, and the other interface that we've got, and we'll enable that one in there as well. So let's have a look what's actually happened. Let's show IPv6 route, and there's some other bits and pieces in there, and there we have it. So we've just hit enter there, we didn't put any summary or anything like that in. So based on this route that we've got, router 3 has acquired via RIP this address, so 2001 COFFWE1/64. There's our administrative distance at 120, and it's found via serial 000, and it's coming in via the link local address. Because I don't know if you noticed, but I don't have actual network numbers running between the routers, and it seems to be working. The only bit I'm a bit worried about this in here is this /16. If that's the number of hops, generally in RIP, that means it's a poisoned route. So it says don't come through here to get there. Not too sure why at the moment. RIP has also given us number 3 network down here. So that's the number 3 network up here. This is the 2 network, and this is the 1 network. The 1 seems to be poisoned. Network number 3 is got 2 hops, and it's bound by serial 001. So there, effectively there's 1 hop there, but it's using the link local addresses to actually manipulate and do everything. So that's cute, that one. So seems to be working. So let's have a look at router 2. Show IPv6 route. So we've got a few other little beasts on there. Here's our 1 network and our 2 network. The 2 network also seems to have 16 hops. We've got our static in there, and everything else is directly connected. So we should be able to ping things. Let's try and ping from this router, or this PC rather, down to this PC. So just make sure. So that's my address. So 2001 COFFWE2 and 10. Everything else should be correct. And we'll pop onto this PC and ping that address. See if it works. Should it work? Well, ARP still runs. It seems to be having an issue. So let's have a look at our router. 2001 COFFWE. Actually, do I have an IP address on this machine? No, I don't. I need to auto config, you silly man. Okay, we're troubleshooting as we go, aren't we? So we've gone auto config. It's using Slack to actually acquire the address. That's actually the reason I came to this top one. Go back into that, hit the up arrow, and see how that goes. Well, that's a bit better, isn't it? So a little bit of troubleshooting in there. It's nice in packet tracing, but there it is. We've got a reply from that to this network. So this is the 3 network, which is according to our router. Oh, so it's the 2 network, beg your pardon, is that path there. Now it does say 16 hops, which under IP version 4 RIP is a poisoned route, but it got through quite happily. So perhaps a packet tracer issue, eh? Needs work. So yeah, show IPv6 RIP, and all good. So RIP giving us the 2 network, the 3 network. One thing we'll see in here, we don't have any external networks coming in. We did redistribute static, doesn't seem to like it at the moment. Next time I'll do it on physical equipment and we'll see what it works out from there. But at the moment, that's RIP with IPv6. And that's us done. So thank you for listening.